Padres, welcome back. This week we have an astrophysics test. So we're going to talk about what's on the test, how to prepare for the test. For that though, a few things. First, if you have any missing work for the astrophysics unit, please turn it in before you take the test. The reason we do all these homework problems, homework sets, is to prepare us to learn, to prepare us for the test. So I will give you partial credit if you email me any missing work before you take the test. After you take the test, I'm not going to give you any points for it. So that's the first thing. Let's kind of jump in. Let's jump in. So the test is going to be worth 100 points, which is normal. It's going to be 25 questions. You have until Friday at midnight to take the test. So that gives you all week to complete any missing work, gives you all week to study, take the test on Friday or before Friday, and there, as of right now, are going to be no retakes. So make sure you do a good job on this test, study hard, and get it right. I am timing the test. It is going to be 30 minutes. The reason I am timing the test is because it is going to be an open note test. And because it is an open note test, I do not want you looking up every single answer to every single question. If you need to do that, you clearly do not know the material and you should not be getting a good grade. So I'm hoping by setting a time limit that you should know most of the questions and be able to answer them. And then those questions that you're not sure about, you can use your notes to look up the answers to those questions. And what I would recommend you do is just like a normal test if we were in school. Instead of creating an index card, though, I would put it on a normal piece of paper. I would go through all your notes, all the problems, review everything, and anything you don't know, write it down on a piece of paper. By writing it down again, you're helping it sink into your head, and then you'll have one sheet with kind of like the highlights of everything from your notes on it. And then just put the things you don't know on there. And so that way, instead of flipping through pages and pages of notes, you'll have it on just one sheet of paper. So that's my recommendation on what I would do if I was taking this test. I recommend studying for at least an hour. There is no math problems on this test. It is all concepts. So things to study. Obviously notes, every single question can be found in the notes. There's a practice test that I put up. The answers to the practice test are also there. This is optional. So if you want some more practice problems, they're there. And then of course the weekly homework problems, there were 4 sets of them. Go through, review those again. You have the answers to those. And also make sure that you can answer any similar questions. For example, if there was a problem on the celestial bodies homework, which said, give you a picture. I think I gave you one with a picture of something, like an asteroid or a comet, and I said, what is this? Well, if I gave you a picture of something else, could you name it? If I give you a picture of a nebula or a minor planet or a moon, could you name it? So just because the question on the homework was, can you name this, and it's a asteroid, you name other celestial bodies. So think about the questions from the homework and the questions from the practice quiz. If the question is tweaked a little bit, could you answer that? So think about that. So for the concepts, which is the whole test, the first unit was on, or the first part was on celestial bodies. So you should know asteroids, comets, meteors, meteorites, meteoroids, minor planets, galaxies, universe, all those terms. You should be able to identify pictures of them. You should be able to kind of know what they are. The second section had two parts. The first part was on particle physics. So it had 6 quarks. So the quarks are up and down. Those make up all matter. So our protons, our neutrons are made up and down quarks. And then the more rare ones are top and bottom, strange, and charm. There are 6 leptons. The one you know is the electron, and the other 5 are the tau and muon, and then the neutrinos. So you have an electron neutrino, a tau neutrino, and a muon neutrino. And you have antimatter. Antimatter is just like those 12, those 6 quarks and 6 leptons, except they have opposite charge. So everything else is the same, but opposite charge. And when matter and antimatter collide, when an antimatter particle collides with its matter particle, they annihilate into energy. So if you have a proton and an antiproton and they collide, energy. But if you have a proton and an anti-muon, they'll just bounce off each other. But if they hit their opposite, energy happens. And then know the 4 forces of nature. And so using the particle physics, we talked about how everything was made from the Big Bang to today. So you should kind of know kind of just like the big parts of those stages. We talked about dark matter. Galaxies are spinning much faster than they should. There should be way more mass there to hold them in place. They're spinning too fast. And so the thing that's there holding them together is dark matter. We don't know what it is. And dark energy, we said that the universe is expanding. All the stars are going farther away, and gravity should be pulling them in, but they are accelerating. They're speeding up. So something has to be pushing them farther or faster away. So that's dark energy. We don't know what that is either. And in the fate of the universe, what could happen to the universe? Our third section was on stars. So you should know we had very low mass stars, we had low mass, we had high mass. You should know the life cycles of those. We talked about what elements are produced in low mass stars and what elements are produced in high mass stars. We talked about stellar objects like pulsars and quasars and binary star systems and globular clusters. And we talked about unique stars. Those were stars that I thought that you should know, like Polaris is always in the north, and Sirius is the brightest star that we can see, and there were a few others. The solar system. This was the past week, so you should know how the solar system formed. You should know the objects in it, like the asteroid belt, like the Kuiper belt, like the Oort cloud. You should know why planets have rings. You should know what planets have rings. You should know, why the asteroid belt is there. In kind of the trends of the planets. That was the last question. So make sure you kind of know which planets have more moons than the other ones. Or which planets, what's kind of like a general trend for the spacing between the planets, or a general trend for how fast they're spinning. Do they all spin at about the same rate? Like, is their day about the same as the Earth, or is it, are their days faster or slower than the Earth? So kind of like some general trends of the planets in our solar system. And that's it. That is it. So, be ready by Friday. Like I said, one and only chance. It is open note. It is timed 30 minutes for midnight on Friday night. It's going to be open all week, so you can take it on Tuesday if you want. I will post the results Saturday morning, and I'll enter them into Moodle, not to Moodle, Aries, and I'll open it up in Moodle so that you can go through and check your answers to see which ones you got wrong. Don't forget to turn in any missing work for astrophysics before the test. There will be a few chances to ask me questions. You have Tuesday's Zoom session and Friday's Zoom session, and of course Wednesday by appointment. And then I'm always available via email. So if you have any questions on something, email it to me and I will get right back to you. And that is it. So have a great day, Padres.